My name is Marius. I'm from Lithuania, and today I'm going to talk about analyzing data with descriptive statistics. So let's start. Okay. So when I was at the age of 13, I really, about the age that would qualify me for a STATWARS competition, I was really I didn't really think that I would become a data scientist, because data scientist position didn't even exist back then. So instead, I was pretty much convinced that I would become a rapper. I listened to hip hop music, and I really thought that I started writing some texts, and I thought I would become one. But I didn't have any good stories. So instead, I decided to talk about, I decided to pursue a different career. Maybe an office job would be more suitable for me. So that's why I decided to become a data scientist. Now, in school, I really liked numbers. I really liked math. I liked economics subjects. And for example, economics class was really fun because we used to play some games like creating fake companies, or tracking prices in supermarkets. So so this really looked interesting to me, because you're putting data or numbers into real context. So because of that, I thought that I would do something with my career similar. So I decided to study applied economics and applied statistics and econometrics. And later on, I became a data scientist. So that's a little bit about me. So currently I work at Beyond Analysis. This is a UK data analytics company. So we have various clients from different sectors, and therefore we work on different problems, from travel to retail and stuff like that. So some of the interesting things that we do is, well, we try to predict the future with numbers. So imagine that you're a business owner and you have multiple stores across UK, let's say hundreds. And what you may want to know is, how will your business, how will the stores perform in the coming months? So this is where data science comes in, because a data scientist will train a model on historical data, and the model will learn the historical patterns. And based on that, we will forecast the future sales. And this way, the business can be better prepared for the future demand in the coming months. The other thing that we do is we do customer segmentation. So for example, if you're selling products, you may want to group your customers into certain segments in order to understand better what their habits are, which customers are unhappy. So if you understand your customers better, this way you can actually provide better services for them. Now, the third thing that we typically do is we create interactive dashboards. Now, for example, if you're a business owner or a manager, then you probably know a lot about the business side of things, but you probably don't know a lot about statistics or programming. So maybe, so this is where data science comes in. So what we would do is we would create a dashboard for the data that the business is generating, and the manager can then, interact with the dashboard. He can slice and filter the data and get some key pieces of information with visuals or tables and stuff like that. So then the manager can make data-driven decisions. So I've prepared, I will run you through a simple example in real world data. And so imagine that you become a successful data scientist, and the company that you work for asks you to move into New York. Now, you think that this is a good opportunity, but if you move in there, you have to live somewhere, right? So why not buy an apartment? And maybe data can guide your decision. So here's a snapshot of real data of New York apartment prices. And so I've collected this data myself. And one thing that you need to know about data scientists is that a lot of time in data scientist is consumed by actually preparing data. So you need to clean it, you need to transform it before it's suitable for analysis. Because real world data might be messy and not in a format that you want for the analysis. So here is, you see the data with several columns that I've selected, and I've done the pre-processing myself. So the first thing that I like to look at the data before analyzing is, what are the variable types? So here we have 3 numerical columns, which represent amounts. So we have apartment square meters, we have year built, and we have apartment price, right? So, and not everything that looks like a number, that is a number, is actually a numerical column. So for example, if you have something like a tax code that's represented as a number, it's probably a categorical column, and you don't want to perform numerical operations on such columns. So this brings me to the second variable type, which is categorical, and they represent groupings. So for example, borough, neighborhood, and what you can typically do with these variables are either group by them or perform some counting with them. So let's move on to the next thing that we typically do is if you're analyzing data, you're typically summarizing it. So we have the typical summary statistics that we use is mean, median, and mode. Now imagine that we have 5 students which get different allowances. And what we want to understand is, what is the typical allowance that these children get? Now, this is not so straightforward to answer, especially if you have larger amounts of data than here. So in the first case that we see, the typical allowance ranges from 100 to 200 pounds. And I'm sure that you're familiar with the most popular summary statistic, which is arithmetic mean, where you just sum all the allowances and divide by n, which is 5 here, and we arrive at number 150. So, and 150 seems like it's a good description of all the students' allowances in the case 1. Now we have a second case, which is a little bit different, because we have four of the students are the same, but the 5th one has rich parents, and he gets 1,000 pounds. Now, what happens when we try to calculate mean? So we arrive at the number 320. Now it seems that it's not a very good representation of what a typical student's allowance. So instead, because mean is really affected, easily influenced by outliers. We call an outlier in statistics such a data point which is very different from the rest of the data points. So in this case, students. So this student that gets 1,000 pounds is an outlier. So instead, we may want to calculate median. And so median, the way median is calculated is that we sort values from the smallest to the largest, and we take the middle point value. Now, in the first case, we have 150 pounds, which is actually the same as mean. And in the second case, we get 200 pounds. So now it seems like a better representation of the overall sample of students. Now, the third summary statistic is mode, and it's more often used actually with categorical columns, because what it is, it's just the most frequent value within the set of data. So, for example, here we see that some of the students get, 2 of the students get 100 pounds, and 2 of the students get also 200 pounds. So this means that we have not a single mode, but 2 modes, and they are 100 and 200 pounds. So let's get back to our example of New York and try to apply something like some of those summary statistics. So let's imagine that your new workplace is in Manhattan, and it's the iconic borough which has Central Park, Times Square, and all the other landmarks. Now, but if we want to understand where would be the most affordable place to live, we can try to calculate mean for each of the boroughs. So for example, if we do that, we can quickly observe that Manhattan is actually very pricey. It's more than 3 times expensive than the other boroughs, and the other boroughs are more or less equally priced. Now we can also observe here that the average year built suggests that the Manhattan has the oldest buildings, and we also can learn that, for example, if we want the largest apartment, then Staten Island may be the option because it offers the most square meters on average. Now, if we move to the next slide, we can see that let's say that you decided that you want to live close to Manhattan and heard that Brooklyn is a hip place with lots of restaurants. Now, maybe you want to search for a place in Brooklyn, but your budget is only $400,000. Now, it's quite below the average of what is apartment price in Brooklyn, but it's not a problem because we can actually filter the data in Brooklyn below £400,000. We can quickly visualize it with a bar chart, and we can see the overall distribution of average prices by neighborhood. And what we see is that what's within our budget is we see that, for example, Coney Island is very near our budget, almost $400,000. And also we can observe quickly that we have Brownsville and East New York, which are relatively cheap neighborhoods. But unfortunately, the data that we have is limited, and it doesn't help us. It cannot help us to answer the questions why these neighborhoods are cheap. So maybe their location is not that good. Maybe they're industrial neighborhoods. Maybe the apartment houses are residential buildings there are outdated. So it's not always so that we may always come up with interesting questions, but it's not always easy to answer that because data has some limitations. Now, the last concept that I want to talk about is correlation, and it's sometimes you want to know the relationship between two variables. Now, and the correlation is the most popular technique to do that. So if there's a relationship between two variables, when both of the variables move together, then we say that we have a positive correlation. So on the right, you will see some made-up examples. For example, the more ads are clicked on Facebook, the more sales they will generate. So here we say that the correlation is positive. Now, what is a negative correlation? When the relationship is inverse. So when one variable increases, the other one decreases. And there's a silly example over here. So on the bottom, where the more hours you work, the less free time you have. And this is a very, very straightforward, and it's really you're subtracting your hours worked from the free time you have. So yeah, the moral here would be that if you want to have more free time, you should work less. Now, if you want to calculate correlation coefficient, you can do that, for example, with Excel, with the Corel function. You would need to supply two numerical columns, and you would get a single number, which is the correlation coefficient, and values near 1 indicate that there's a perfect positive correlation. Values near -1 indicates a perfect negative correlation. Now, if it's near 0, that indicates that there is no relationship between the different variables, or it can also mean that the relationship is complex. Now, remember that since we are compressing data into a single number, it's not going to work for all the cases and explain everything. So you need to additionally visualize data or calculate other measures, because it's not going to be an answer to all of the problems. And just quickly look at how does the correlation look in real life? Well, you would expect that a larger apartment should cost more, right? So a positive correlation. Now, in this data, in a particular neighborhood, we observed that there is a moderate positive correlation between these two variables, and it's equal to 0.3. Now, even stranger things happen when we look at year built versus apartment price. Now, you would also expect that more recent buildings should be more expensive because they're new. Now, it's not the case here. So we have a very weak negative correlation, and we can observe that. Most of the large portion of buildings are actually very old, more than 100 years old. And there's also a portion of buildings which are built very recently. And we can see that the older buildings are actually a little bit more valuable. So this could indicate there may be some hidden factors that we can't observe within this data. So for example, the old buildings were built in a better location, or the old buildings were have larger apartments. And this is something that requires some more complex methods. So for example, if you will take a statistics course, you will learn about regression analysis, where you will use multiple variables, and you will then able to estimate an isolated effect of each of the variables, and it would be more suitable for these more complex and multidimensional problems. Yes, and to summarize, so we've looked at those summary statistics. They're quite powerful because they can compress large amounts of data into a single number, but we need to understand that some single number will work, the single summary statistic will work in different, for different scenarios, and you need to calculate really just not a single one, but it's more useful to calculate several of statistics and put them together with visualizations to get some quick and easy insights, to get a better view of the data that you have. And yeah, another thing that I want to note is that real world data typically requires some cleaning, and it may not easily reveal relationships. You may need to use some complex methods. So that's why if you want to become a good data scientist, then you really need to work on different problems, and you need to be interested, you know, in the different methods that are used, and read the latest research in order to keep up with what's happening, and in order to be able to use appropriate methods for a particular analysis. So that's it for me, and yeah, good luck in the competition.
Thank you for that, Marius. That was really interesting. I'd never realized that older buildings are more expensive. It sounds really backwards.
Yeah.
Yeah. So do you on your LinkedIn profile, it says that you work a lot with like machine learning. Can you give us a bit more of an insight into that? Because it seems like a really interesting aspect of data.
About machine learning?
Yeah.
Yeah, so it's really yeah, the complex. Basically, I would just say it like that. So before I don't know, before this century, we only had statistical concepts which were more interested in actually learning about the data. So what are the relationships between the data? And in this century, we've shifted to different problems. So for example, we're now quite interested in the predictive algorithms. So we want to, I don't know, forecast sales, or we want to understand if a customer will actually leave your company, stop being a customer. So in order to answer this, you use the predictive algorithms, which are called machine learning, and they basically, you feed some historical data into your algorithm, and based on that, it learns patterns. And based on those patterns, it can actually, if it's able to generalize across the population, then it can provide predictions.
It sounds really complex. Do you think that's the most difficult part of your job then? Or what is the most difficult part of your career?
So actually, again, so the field is evolving very rapidly, and it's quite, you need to focus on a certain aspects. So for example, we have even in data science. So right now I'm talking about data that's in the tables and in similar formats, but there are some various different ways. For example, there are some of the data is not in this format, so it can be something like text analysis, which is called natural language processing, or computer vision problems. So for example, those visuals, those funny hats that you use in Snapchat, so this is data science behind that, complex machine learning algorithms. So the thing is that it's really difficult to keep up with all the technology that's there, with all the latest research that's doing. So you always need to be interested. And yeah, but one of the complex things in today's work is, of course, is to actually prepare the data for the analysis. Sometimes people say that it may take up to 90% of the time.
Wow. So we have had a question. What do you think is the best method of finding data?
Finding data?
Yeah.
Well, finding data. So there are lots of different sources. So, I mean, for example, if you're talking about even the governments, for example, in the United States, in UK, there's some open data sources. There's also, it depends on your purpose. So if you want some real world data, well, so you would probably use an open government source like I did. But then if you want to have some good toy data sets, so sometimes you're not interested in the cleaning process, but you want to apply the machine learning algorithms. So you would use, so for example, there is a page called kaggle.com, which there are some machine learning competitions. So there's a vast number of data sets over there. You can really go and play around, and you will even get there and you will even see other people's work on those data sets. So it's really a very fast way for you to understand data.
Yeah. So are there any standout moments in your career for you?
Yeah, that's a difficult question. So previously, yeah, before this job, I had some interesting interesting job where I had to predict real estate prices. So for example, the building that you live in, its value, it can actually be estimated with machine learning more accurate, with a higher accuracy than a person called appraiser, which has several degrees and lots of experience in the field. So you can, with machine learning, you can do that more accurately. So that was a little bit astounding to me.
Yeah. It seems like you've got a lot of responsibilities in your job. You're working with a lot of big data. How do you de-stress?
How do I what do?
De-stress, like relax after work.
Oh, relax. Yeah, so it depends. I mean, it's all, I guess it's all a roller coaster. So sometimes sometimes there's a lot of work, and it's, well, what I really like to do is try to focus on a single task at a single time. And well, for the distressing part, it's important to maintain your body. Right now, we're spending a lot of time at home. And it's important to, I have a dog, so a dog walk is a good thing. And also to have exercise, so regular exercise. So even though the gyms are not working now, but you can do a lot of stuff at home too, on a yoga mat.
So do you think that the STATWARS competition is really beneficial for future data scientists?
Well, yes. So as I mentioned, at my age, so when I was something like 13, 14 years old, stuff like this didn't exist. Well, at least where I come from, and it's really beneficial to see those numbers instead of plain numbers, to see them in certain context and actually solving real problems. So that's personally the driver for myself that keeps me interested in this.
Mm-hmm. And are there any programs that you use in your day-to-day life or your day-to-day career that you think that you should have learned earlier, or that would have been beneficial to learn earlier?
Programs? Okay, so yeah, so in general, what you need as data scientists, you will need to learn programming. And it was when I started studying statistics in the first course, when I saw programming, I was, whoa, I will never learn it. I will never learn that, and I don't want to do that. I don't want to have anything with that. So, but yeah, you need to learn that. So for example, the most popular languages for data scientists are Python and R. And they have a little bit different purposes. Python is more for machine learning, and R is most focused on statistical communities. So and they're, I would say, quite one of those programming languages that are easier to learn. So if you have free time, there are some great courses where that can get you even at a young age. You can really start doing that, I'm sure.
Yeah, they're a really good introduction to data, I think, as well. And speaking of which, yeah, are there any, you know, apprenticeships that are beyond analysis, or what kind of degrees do you think that students should approach to try and get into data?
Degrees, so, well, it depends. Actually, so it's yeah, this field is evolving rapidly, and so the future, the kids of today, the roles are not even there yet, probably, that they're going to apply. So, for example, we have data scientist, data engineer, machine learning engineer, data architect, data engineer, multiple ones, and they have different aspects. So for example, typically people come from either a mathematical background, so something math, statistics, econometrics, like I do, and we're more comfortable with statistical analysis. And some other people come from IT backgrounds. So for example, they don't want to do IT job, they want to do something with machine learning or something like that. So with the engineering aspect, create the infrastructure of how the data flows and stuff like that. So yeah, so I would say that mostly IT and math, but you can also come in from social sciences as well.
Mm-hmm. And we have had another question. Is it important to work collaboratively in your career?
Yeah, so if you will, one of the things that's useful, if you're thinking about pursuing such career, then you should go to job advertisements, and you will see what are the requirements are. So for example, you can go to LinkedIn and see job descriptions. And one of the things that will come up typically is being a team player. So, and it's you can be a very good specialist, but if you don't collaborate, then it's really difficult, because most of the jobs require more than one person. And it's really, a company will not want, you know, all of the knowledge in one head, right? So because if that person goes on a vacation or he decides to leave, then he takes out that knowledge with himself. So that's why you need to, yeah, it's an important aspect.
Yeah. And what is the largest or most interesting project that you've worked on?
Well, yeah, so the recent one was the demand forecasting, which was really about forecasting sales. And we also wanted additional aspect, is we wanted to understand the drivers, the historical drivers of why, what are the reasons why, where the sales were driven for whatever reasons. So that was something interesting. But yeah, of course, as well, predicting real estate prices is also something very interesting, because the challenge there is that it's hard to actually get data. So you can have the greatest methods in your head, but if there is no good data, then there is a saying, garbage in and garbage out. So you need to first start with a good data set. And
we're kind of running out of time, but do you have any advice for the young and budding data scientists that are watching today?
Yeah, so try to work on, expand your horizon, and try to work on different problems, and read on different subjects, and yeah, just go pursue what's the most interesting for you, because data science has a lot to offer, and it's data is the, I don't know, the thing of this century. So I think that it's a good way to go.
Okay, well, thank you for that. So that's all we've got time for today. So thank you, Marius, for taking time out of your day to join us today. And thank you, everyone that's been watching. If you feel inspired to take on the STATWARS competition, then you can head to www.statwarscompetition.com, and hopefully you'll get some inspiration. You'll start designing some data sets for different projects. So thank you, everyone. I think we'll end it there.